Before we start the distillation, we need to decide if it will be a simple or a fractional distillation. So according to Sci-Fi Online, the boiling point of dichloromethane is 39.75 degrees Celsius, and ethyl acetate has a boiling point of 77 degrees Celsius. So since there is more than a 30-degree difference, we could do a simple distillation.
So now we have the simple distillation apparatus set up. Our Bunsen burner flame won't touch the iron ring, metal pad, or the round bottom flask. We have an elastic bands around the sprout on the condenser and the thermometer adapter to prevent the condenser from falling. We have greased our glass joints together to keep the seal and allow easy dismantling. We also added some glycerol to insert the thermometer easier into the adapter. The water flows into the bottom of the condenser and out to the top, and we also have the thermometer positioned at the correct spot where the mercury bulb is just past the condenser tube. At the end of the condenser, we also have a slot bucket to connect the forerun for the very beginning of the distillation. Now we can actually start the distillation. First, we need to take down the atmospheric pressure for the day because the boiling point is affected by the atmospheric pressure. Boiling point is the temperature when the vapor pressure equals the atmospheric pressure. We have a mixture of dichloromethane and ethyl acetate connected and ready to be distilled. Now we have to start heating up the mixture to slow boil. We light the Bunsen burner away from the setup in case of a big flame. There will be a few drops that boil off that may be impure, so we discard the forerun into the slot bucket. Then we can switch to a different container, such as an Erlenmeyer flask, to hold the dichloromethane, as it will boil off first. There might be times when the temperature spontaneously increases or decreases when we need to switch the slot bucket. Once the temperature stabilizes, we can go back to collecting our wanted solution.
So the drops being collected actually slowed down, and we have finished boiling out the dichloromethane. There will be a decrease in the temperature because there's not enough of the ethyl acetate vapor that reaches the thermometer. So now we keep heating the ethyl acetate until we get to its boiling point. So we're going to keep heating. And we're going to switch out the Erlenmeyer flask for another one to get ready to collect the ethyl acetate.
So now we have two solutions that have been separated, but now we need to check for purity. A simple way to do this is to conduct an infrared spectroscopy of both the dichloromethane and the ethyl acetate and compare to the original spectrum of the pure compound without impurities. Infrared spectroscopy shows the fingerprint or the specific structures of a molecule. If the solutions are pure, the spectrums will match to their known pure form. If they have any impurities, they will have different bands in the spectrum, indicating that different bonds that are vibrating.
Another way to check for impurities is through gas chromatography. We can do a gas chromatography for dichloromethane and ethyl acetate that we know is pure, and do another separate gas chromatography for our solutions of dichloromethane and ethyl acetate. So if the separated components differ in our chromatography, there may be impurities.